So today we're going to talk about Learning Target 6, which says I can identify key features of a graph of a function. So if we're looking at this graph here, first it is important to recognize what the important parts are. Some of the important parts, or we are going to call them key features of a graph, are these right here. So starting with the x-intercept is any place where a graph crosses or touches the x-axis. And remember, if I'm writing too fast and you need to stop, feel free to pause the video and then catch up and then hit play again. So looking at this graph up here, the x-intercepts are there and there and there. So this graph has three x-intercepts. The y-intercept is any place, or any place is, if it's a function, I'll just have one though, any places where a graph crosses or touches the y-axis. So in this graph, the y-intercept is right there. The maximum point on a graph is the highest point on a graph. So the highest point on a graph, we'll say the greatest y value. Now often graphs don't actually have a maximum. For example, this graph does not have a maximum point because even though this looks like it might be the highest point, if you keep following the graph over here, and this is going to continue, it should have arrows on the end. If this is going to continue, there actually is no highest point because if this goes up to infinity, you'll never find a point that actually is the highest. So be careful with that. If a graph goes up and up and up, there is no maximum point. The minimum point is the lowest point on a graph, the lowest y value. So again, even though this seems like it might be the minimum, it actually is not because this x over here goes lower. And because there's an arrow on the end, it goes lower forever, so there's no point, in like specific point that we can call the minimum. Now the maximum and minimum are often referred to as the absolute maximum or minimum. That's another way to refer to those. Now, in addition to the absolute maximum and minimums, there's also something called a relative maximum and minimum. That's what these types of points are. So a relative maximum on a graph is a point that has, or that, we'll say, a point that is higher than its surrounding point. A point that is higher than its surrounding point. So for example, this point right here, the points that are surrounding it are lower than it, so this is higher than the surrounding point, so this is a relative maximum. It is a maximum relative to the points around it, and here's another one. This point right here is higher than the points immediately surrounding it. So in addition to being the y-intercept, that's also a relative maximum. The relative minimum is a point that is lower than its surrounding points. So in this graph, that would be a relative minimum. Now the difference is up here, if you think about, well, a maximum and a minimum, an absolute one, that might look something like this. Like a quadratic function, that has an absolute maximum, or an absolute minimum. Okay? So there's a difference. The absolute maximum or minimum, or sometimes just called the maximum or minimum, is the highest and lowest point on the entire graph, which oftentimes doesn't actually exist if the graph goes to positive or negative infinity. The relative maximum or minimum is a point that is just higher or lower than the points around it. Intervals of increasing or decreasing. To discover intervals of, or to identify intervals of increasing and decreasing, you have to think about reading from left to right. So looking at the graph going from left to right, if graph goes up, then increasing, if graph goes down, then decreasing. And this is often written as a domain. So if we look, I'm going to draw a line here. If we look at when a graph is increasing or decreasing, we usually write that as like a spread of numbers on the x-axis. So for example, this graph is increasing. You kind of follow that down. That's about 3.5 up there. So going from left to right, this graph is actually going up in this section of the graph. So everything less than 3.5, the graph is going up. And then from 3.5 to about 2, it's going down. And then from 2 to 0, it's going up. So we'll write from negative, oops, that should be a negative 3.5. From negative 2 to 0, and everything in between, the graph is going up here from negative 2 to 0. From 0 to about 2.5, it's decreasing, it's going down. And then from about 2.5 on, it's increasing again. So for all of the x's that are bigger than about 2.5, these are all increasing intervals on our graph. X is smaller than 3.5, x is in between negative 2 and 0, and x is greater than a positive 2.5. Those are all the spots on this graph where the graph is increasing. The decreasing spots on the graph would be from about negative 3.5 to negative 2, it's going down. So from negative 3.5 to negative 2 and all the x's in between there, it's going down. And then again, from 0 to 2.5, it's going down. And all the x's in between there. Those are decreasing intervals. Now the reason that I'm not saying less than or equal to, I'm just saying less than, is because at the point negative 2, this graph is neither increasing nor decreasing, it's just flat. It's at one little point right there. There's two more, and we're going to keep practicing this and working on this, so don't get too overwhelmed if this is kind of confusing right now, because we'll keep practicing this and working on this over the next week. The end behavior of a graph, the next key feature is exactly what it sounds like. It's what the graph is doing at the end, how it's behaving at the end. So we will say how the ends of a graph are behaving. And there's two ways to write this. You can either write it with words or with arrows. So if we think about this graph up here, the left side is going down and the right side is going up. We ignore the side-to-side motion of it. We just know that end behavior usually just talks about going up and down. So the left side is going down, the right side is going up. So we're going to write down for the left side, up for the right side. That's how you write end behavior. So it's like the left side and the right side, just reading from left to right. Now if you don't want to write words, you could also write arrows. You would say a down arrow and an up arrow. That's another way to write the end behavior. So you can say this or arrows. An asymptote is so we're going to look at this graph for an asymptote because we know that an asymptote is a line that a graph gets closer and closer to, but never touches. Now asymptotes can be horizontal like this. It gets closer and closer and closer to this straight across line here, but it never touches it. Or they can also be vertical. But in Algebra 1, we're only going to talk about the horizontal ones. And the way that we write that is, in this case, it's the x-axis, or we could say the line y equals 0. There's two ways to express this line right here. You can either call it the x-axis, or it's the line y equals 0, because you don't go up or down on the y-axis, you just stay right here at 0. Now let's say we have a line like this. It gets closer and closer to -2, but never touches it. That has an asymptote that we would call y equals -2. It gets closer and closer to this line right here at -2, but never touches it. Okay? Or if you have one up here maybe, it could be at 5 if the whole graph gets shifted up. That would be y equals 5. Okay? Because they're always lines going up, moving up or down, but they're always horizontal, we always use the y, because they always cross right through the y-axis. Okay, so straight across, imaginary straight across line. And that is all the key features that we are going to be talking about for Learning Target 6.